In calculus, it is very important to find the derivatives of many different functions, which is why today I'm going to go over 3 different rules to help you do that in under 60 seconds. Ready, set, go. It is very important to first know the derivative of a basic variable with an exponent. So the derivative of x to the power of a equals a multiplied by x to the power of a minus 1. Now we start with our first rule, the product rule. The product rule states that if we have two things multiplied by each other, let's say a times b, the derivative of that will be a multiplied by the derivative of b plus b multiplied by the derivative of a. That's all relatively simple, but things get a little bit more complicated with the quotient rule. We use the quotient rule when we have a fraction of one thing over another. Let's say, for example, a over b. Now the quotient rule states that the derivative of that will be b multiplied by the derivative of a minus a multiplied by the derivative of b all over b squared. Now finally, the chain rule is when you have one function inside of another. It states that the derivative of that sequence of functions will be the derivative of that outside function leaving the inside as is, multiplied by the derivative of that inside function. There you have it, 3 different differentiation rules in under 60 seconds. Now you're ready to go out there and find some derivatives.
The derivative of sine of x is cosine of x. The derivative of cosine of x is negative sine of x. The derivative of tangent of x is secant squared of x. The derivative of secant of x is secant x tangent x. The derivative of cosecant x is negative cosecant x cotangent x. The derivative of cotangent x is negative cosecant squared x. The derivative of e to the power of x is e to the power of x. You also use the chain rule for that one. For example, the derivative of e to the power of 2x is the derivative of e and then derivative of 2x, which would be 2e to the power of 2x. Thank you and goodbye.
Are an essential to calculus and is often the first part of calculus that you learn. Remember, limits are where a function is approaching, not the point that it is at. On a graph such as this one, at the value of x, the function is approaching 1 no matter from which side. It is clear that the function's limit is 1. However, what if the graph looks like this? The function looks to go to 1 for both sides, but at that point the value jumps to 2. For limits this does not matter because the keyword is approach. From both sides, the function approaches 1, so the limit of the function is 1. What about this graph though? The limit of the function is 2 from one side, but 1 from the other. In this case, at that point, the graph has no limit. Substitution is the first method. To find the limit of the function, plug the x value in, that is below the limit sign, into the function, and as long as the denominator is not 0, then you have a limit. A little bit harder way is factoring. If you plug in the x value and there is a 0 in the denominator, then this is one of the ways that you can solve it. All you have to do is factor your equation, then you cancel, then you solve. It is very efficient and also a very easy strategy. The final way is to rationalize the function. You do this by multiplying the numerator by the opposite of itself. Then you distribute the number and then you can factor and solve. In such a short amount of time, we covered what limits are, how to find limits on a graph, and how to solve them algebraically. Well done. Feel free to pause the video and go back to any of the equations or graphs so that you can see the work in a slower manner.